Okay, welcome back. If you watched the previous video when we looked at the normal um, bell curve for IQ, um, if you have not followed back this video, I will put the information in my description and also above this video. So, continuing with the bell curve, one of the areas that I do want to talk about is the empirical rule, right? So let's get comfortable with math. Let's get comfortable with research, right? This is what I'll probably call it. All right, so let's get comfortable with research. So we're talking about today the empirical rule, right? The empirical rule is also called, some people might call it 68, 69, well, 95 actually, or the 99.7 rule. I know it's long for no reason. Empirical rule sounds better than the saying 68, 95, 99.7 rule, right? But the goal of this empirical rule is that it is a guideline for understanding how data is distributed in a normal bell curve. All right, in a normal bell curve, right? So I'll draw a bell curve. All right. Okay, I did pretty good with this one, except for a little bit at the end, but hey, we're not going to count that. All right, so when we look at the 68%, right, these are percentages, right? 68%, 95%, 99.7%. This just looks at the area. So 68%, I would say it will be roughly here, right? It's a little off. So let me try to make it a little more even. Even if it's not on the lines here. But yes, this looks better, right? So we would say 68% of the bell curve is here. And you might ask, well, how do we get to that 68%, right? How do we come up with this number? So with the empirical rule, this is broken in half, right? And this is 34%. And another 34%, right? So 34 plus 34, of course, is that 68%. All right, keep in mind, this also looks like -1, also +1, right? In the previous video, we talked about intelligence bell curve, right? We also have it listed as, and I can see if I can put it here without being confusing. So let me just move this down some. All right, so we can have the 68% here, right? This is covering that part of the bell curve, but we can also say, as what we did earlier, we had 85 to 115, right? And of course, zeros here. But for an IQ bell curve, this will be 100, right? Because we're looking, this will be an IQ standard deviation, but a normal standard deviation is going to have -1 and +1, right? So I hope that you are bearing with me here, right? So when we look at the empirical rule for the 95% 5%, I'll give you time to think about what percentages go on each side of this bell curve. And then we can go from there. So maybe you can pause this video, and then if not, let's just figure this out now. All right, so our next line goes here. Ideally, it's a little far out, so we move that in a little bit. Okay. So if we're looking at this bell curve and we're looking at this line, right, we have to understand what the percentage is inside this bell curve here. So it would be 13.5%. And the same thing, because you think about a normal bell curve, it mirrors each other on the other side. And so it's going to reflect the same number. If I fold this bell curve in half, right, that's that term that means that it's the same on each side. So this is what makes it symmetrical, right? All right, so do it on one side, do it on the other side. So all we're doing is adding more of the bell curve with all four of those percentages, and we're going to get 95. Now you might see a little different with the percentages, but it's literally the same thing with the empirical rule. These percentages do not change. All right, so now we have the next area here and here, right? So this will be 2.35%, 2.35%, right? So we know this is that 99.7%. All right. So it's more about covering how much of the data is covering these areas. Like, where does our data fall, right? And one of the things that the bell curve for the empirical rule is good for is that it helps detect outliners. Right, outliners are scores that are like extreme, like they're all the way out from the norm, right? Either way, negative or positive, right? So abnormalities. Maybe I gave a easy test to 12th graders. Maybe I gave them a kindergarten test, right? Of course, they're going to have extreme outliners because, right, that's something that they should have been given anyway based on what grade they are, right? So it's to look at things or data that it might be significant in doing more thorough investigation, right? And then we look at, it helps with the guidance for interpreting scores. All right, interpreting scores, right? So remember we talked earlier in the earlier video about IQ bell curve. If this person Keisha, who scored 145, all I'm going to do is add this 15 again because we said that standard deviation for David Wessler is 15. This 15 tells us what to do on the x-axis, how to count forward and backwards, plus or negative. Right, and we talked about how all we're doing is adding on one side and subtracting on one. So if this person scored 145, all we're going to do is just add this up and see where that number falls. So of course this will be 130, and then another 15 will be 145. All right, so we know that person will be that 3 standard deviation. Well, in this case, so we have the 1 here. I think the number is just not in the proper way. So let me move that over, right? So this will be 2 and this will be 3. So, right. So 3 standard deviations above the mean. So it allows us to interpret scores, right? And it provides valid conclusions, right? How typical or how rare something is within the data, right? We get to learn how our data behave, right? So how the data behaves, right? And it's also easy on the eyes because you can just look at this instead of maybe looking at a bunch of numbers without any graphs, right? So this will be considered descriptive statistics because we're describing our data. All right. So I'm able to describe my data. What did I find? How can I show it to you so you can understand it? Okay. Um, and so also these lines here never touch, right? They never touch because these lines go on forever, right? So these lines go on into infinity on both sides, so they never touch, right? There also is another number besides 99.7, right? But it's never going to be 100% of the bell curve. You're never going to capture 100% of the bell curve, right? So just to go over it again, the empirical rule is a guideline for understanding how data is distributed in a normal bell curve, which is also known as symmetrical. We know the empirical rule just breaks down the bell curve into percentages that never change, right? These never change, right? And it allows for us to continue to see where our data falls, right? Helps detect outliers, guidance for interpreting scores, how data behaves. And this is be considered descriptive statistics because it describes what my data looks like, right? And all we're doing for each of these areas is just adding, right? Adding these sides together, right? 99.7 is just us adding all these scores together. Standard deviation, this is on the x-axis, right? Our standard deviation tells us how are we measuring our data, right? Yeah, so I hope that has been helpful in understanding the empirical rule, right? The empirical rule is important because I can just say we scored within 68%, which is the average. Or I can say, oh, we scored between -1 and +1. Or I can say we scored between 85 and 115. Those are all different ways to say average. Okay. So stay tuned for the next video, right? And I think I had mentioned earlier about how to make research fun, normalize research, right? It's not bad as you think, right? And I hope to see you in the next video.